Geometry, section 10.4, areas of regular polygons and composite figures. What's a regular polygon?
Equal sides.
Okay, so a regular polygon is a polygon with equal sides and equal angles. Yep. Okay, so remember that as we go through this. We're talking about these kind of things. And we want to find the area. And so we're looking for what to do here. So I'm going to start by drawing a circle. Okay. And then I'm going to put a regular, I'm just going to use the one they use. So I'm going to put a regular pentagon in here. Okay. And this is kind of rough drawing it. I'm telling you it's regular, which means I can't prove that the sides are equal and the angles are equal, but I'm going to do it like that. Okay. All right, so I'm going to just throw some things in here. Okay, I'm going to call this C. Oh, there's Angel. Okay. And I'm going to connect 2 points. Hi, Angel. I'll have to take care of your attendance. Okay, in a minute. Okay. So here we go. Here is a regular pentagon. It's inscribed in the circle, correct? What I'm going to, and remember it's regular, so the sides are equal. So what I'm going to do is I'm going to connect this right here. Okay, so the two lines that I just drew are what? They're radii. Yeah, so if I need a radii, I got two of them. The first one is CA, and then CB. So I could, either one of those I could list as, right? And they're equal, right? Because they're radii? Do you agree?
Yes.
Okay.
Can I spell that?
RADII. Okay. Now what I'm about to show you, this is a central angle, correct? Okay. We want to know how big that central angle is. And I'm going to give you a quick way. First of all, let's name the central angle.
C.
Okay, give me 3 letters.
ACB.
ACB. Could I say BCA?
Yes.
All right, central angle. And it equals this arc, right? That it intercepts. Remember that central arc each, right? So my question is how big is angle ACB?
360.
Okay, did you hear her? She said 1/5 of 360. Of means multiply, right? So basically it is 360 divided by n, which is n is the number of sides, right? Right?
Yeah.
So any regular polygon I could do this. So if I switch to a hexagon, it'd be 360 divided by a hexagon. 6. If I switch to an octagon, it'd be 360 divided by,
8.
okay. So this tells me how big that central angle is. In this case, 360 divided by 5 is what?
72.
72. So this angle here is 72 degrees. Do you understand that?
Yes.
All right. Now I'm going to erase that angle because it's kind of in the way. Is that all right? Do you understand it's 72 degrees?
Yes.
Okay. So I'm going to draw this right straight now so that it's perpendicular. And we learned that if it's perpendicular, what did it do to these two segments? We'll call this point A, B, C, D, E, F. This point is F. What did it do to AB? It bisects. It doesn't. So in other words, these are equal, right? This is equal to this. And we know that these are equal, right? And we know that this is equal to itself. So those two triangles are congruent by the SSS theorem, right? Or SSS postulate, I'm sorry. Got it? That makes sense, right? Okay. This figure, this AF, and I wish I could write it on this line segment. It has a name. It's called an apothegm. I'm not making this up. It's called an apothegm. A-P-O-T-H-E-M. Apothegm. And it is the leg of that. It's this version right here, the leg of that, isn't it? And it's a right triangle, right? how big is this angle right here? See my mark right there? So I'm asking, how big is the measure of angle FCB? How big is it?
36 degrees.
Tell me where you got that from.
72 divided by 2.
Oh, there, it separates it, right? And so how big is angle FCA?
36 degrees.
36 degrees. So no matter how big that central angle is, when we draw the apothem in, what does it do to it?
Divided by 2.
It divides it in two, doesn't it? Okay? It divides it in two. Any questions about that? No questions about that? Okay, so if I asked you to label the apothem, you could do that.
Yeah.
Okay, all right. So, there's a formula to find what, remember the name of this section is to find the area, right? So we want to find the area. And they show you how they get it, but I'm just gonna give it to you because I don't know that you're concerned about how they get it. But the area of any regular polygon is 1/2 A times capital P. Now, we have to talk about what all this means. What do you suppose the A is?
Area.
No.
No.
It's the apothem. Times, what do you suppose capital P is? It actually stands for perimeter. That means that all the way around this, okay? All right, so let me show you how this works. All right, you see this is 10, excuse me, this is 10 inches, I'm gonna say. Let's say it's 10 inches, and I just made that up, okay? All right, so I don't have the apothem, what do I have? The radius, okay? So I need to find two things. I need to find the apothem and I need to find the perimeter. In order to find the perimeter, I find this side and then I double it because it's the same as that, and then I have to multiply it by 5. Do you understand that? Okay, now when we plug this into our calculator, we don't want to start rounding off the bat because then our answers are not consistent, okay? So let's take a look at this. If this is 10 inches, all right, and this, we know that this is 36 inches. How would I find this piece here? This piece FB, how would I find out how big it was?
Is it 36 degrees? Yeah.
That's 36 degrees, yeah, I had a terrible time writing it in there. Got it over here, but, okay, I could sense there was a lot of stumbling there. Okay, so yeah, I use SOHCAHTOA, which stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. What do I have in the 10 inches? Which one is it? What side is it?
Oh, the hypotenuse.
It's the hypotenuse, okay? So I'm either gonna use this one or I'm gonna use this one. How do I know that? Because it has hypotenuse. Okay, so I want to find FB. So according to the 36 angle, what is FB? Is it the opposite side or adjacent side?
Opposite.
It's the opposite. So I'm looking for opposite of hypotenuse, which is sine, correct? So FB, the length of FB, notice I don't have a line above it because it's FB. The length of it is the sine of 36 degrees equals, over 1, equals x, which is FB, over 10, correct?
Mhm.
And so FB equals 10 times the sine of 36 degrees. Is that true? Is that true? That's just FB, okay? Now, I want to know the whole thing, right? Right? So I have to double it, correct? So I'm going to take 2 times that, but then also, what? I need to know the perimeter. So there's 5 of them. I doubled it to get this length. Now there's 5 of them, right? So I got to multiply that by 5. So what happens is I get 10 times 10 sine of 36 degrees. Did everybody see where I got 10 and 10? Okay, now the first 10 came from this proportion, right? The second 10 came from I had to double it and then multiply by 5. Kellen, did you see that? Okay, so this is just the perimeter. This is just the perimeter right here, right? Okay.
What is that number above the 10 on like the fraction?
X. It's X.
X. That's X, right? Because I did the sine of 36, Nelja, is this length X over 10, right? Okay. We good? Now, what do I need? Apothem. So I need CF, don't I? I need the apothem. And once again, we have to go back to Soa Katoa. I know my hypotenuse, and I'm looking for this leg, which is adjacent or opposite. It's adjacent, so that would be cosine. So now I have the cosine of 36 degrees over 1 equals x over 10. Is that true? So that is 10 times the cosine of 36 degrees, correct? All right, so that is CF. So I'm going to multiply these two together, right? Okay, plus I got this half, right? Is the formula? So let's do this together. All right? I got 1/2, no, I'm going to go 0.5, 0.5. So if you take out your calculators, okay, 0.5 times, now I'm going to warn you something. I'm going to put a parentheses, 10, parentheses, 10, sine. I like parentheses because I know they work. Parentheses, parentheses, times, parentheses, 10, parentheses, cosine 36 degrees. I think maybe that you wouldn't need all those parentheses. I think you just multiply it straight across and you'd be fine, okay? So if somebody would multiply it straight across, I can tell you what the answer is. The answer is 237.8 inches squared.
I was doing that long before you did that, and I got that answer.
You got that same answer? So you didn't have any parentheses and it worked.
And
That's awesome.
I did the first one, like the first part before we found CF.
Oh,
and
and
then I took it times
okay.
cosine.
So you ended up rounding and it still worked. Okay, good. Okay? Did everybody get that?
No.
Tyra? .8, yes. You got that? All right. Any questions? Okay. Now, I'm going to take the circle away. This is really example 2. And I'm going to look at what's this? If it's regular, what is it called? What is this called if it's regular? It's a square. That means all the sides are equal, right? Okay, so I'm going to draw this in, and that's called what? Now remember, I took the circle away, but what is that called?
Radius.
That is called radius. Okay, let's call that 7 centimeters. Oh, how do I get that in there to say 7 centimeters? Try it over here. That's better, but not great. So the radius is 7 centimeters. So I want to find the area of this, correct?
Mm-hmm.
And I know that you could multiply the sides together and get the area of a square. Well, we don't have the sides, but we could do it. But what I want you to do is I want you to use this formula so that we're used to it, okay? Okay? All right. So since I have the radius, right, what I'm going to do is I'm going to draw this in. What's this called?
A triangle?
What's this guy right here?
Radius.
No, what's this guy called right here? It's called apothem. Okay, it's called the apothem. It's through the middle of half the side, right? Okay, so how big is this angle right there? See where my pin is? How big is that angle right there, where that little point is? How big is it? And tell me why. It's 45. Tell me why. It's half of 90 because there's 4 sides, so 360 divided by 4 is 90, and then we take half of it. Does that make sense? So what kind of triangle is this? 45, 45, 90, right? So we have the hypotenuse. How do you find the side? How do I find the side? I divide by the square root of 2. So I'm going to take 7 divided by the square root of 2, which I believe is, actually, let's not rationalize it. Why? Because we're going to do a decimal anyway, right? Okay, so the apothem is how big? So this is 0.5 times, how big is the apothem?
4.9?
No, the apothem is 7 over the square root of 2, right? Because both these sides are 7 square root of 2, right? Now, here's the kicker. From here to here is 7 over the square root of 2. And then I'm going to double it, right? So that becomes what? 14 over the square root of 2. That means, guys, that one side is 14 over the square root of 2. Did you not understand that?
Wouldn't it just be
No,
two?
I
figured
Oh,
it
no,
out.
no, 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 no. If you multiply this by 2, that 2, they can't cancel because
Yeah.
this one's underneath and this one's not.
I just had to think that through.
Okay.
Because I realized it after, right?
Okay. So does everybody understand that this whole side now is 14 square root of 2? And how many of those do you have? 4. Once again, you can't cancel that, right? So it's what? 16. 14 times 4 is? Is it 56?
56.
Over the square root of 2. Alright, so 56 times the square root of 2. Now, when you plug this into your calculator, I believe you want to, because I think your calculator, because you got division, I think you're going to have to take this divided by, and your calculator puts parentheses here, right? Right here?
Mm-hmm.
And so I think it looks like this. Okay, try that, and I'll tell you, the answer is, it comes, they say it's 98 centimeters squared.
I got 392.
You didn't get it? You got it?
What?
Oh, I got that.
Okay, yeah, I know that.
You probably just
You got it?
Helen didn't.
I'm still writing it down.
Did you have to put those parentheses in?
I'm guessing so. That's correct too.
Yes.
Literally the same answer. Oh my goodness.
Would you help her out if
Yes.
she needs it?
0.5.
You guys got 98?
Yeah, I did.
Yeah.
No, I just explained it.
I literally typed that in. Why am I not getting the answer when you get it?
What did you get?
I got 394. Yeah, 392.
Did you show her how to punch it in?
Yes.
Do you need me to show you again?
No.
Try again. Try it one more time to see if you can do it. Don't forget your parentheses.
I did forget that. I even told more about these things.
Don't forget your parentheses after the square root of 2.
What am I doing wrong?
Helen, okay, let me go through this again with you. Okay, that's right. That's right.
What did I do wrong?
She's like, nothing. You're like, exactly nothing.
Yeah, that's what I'm saying. I don't know why you don't get the right answer.
Maybe I'm doing better. 0.5. Parentheses. Why didn't you just multiply?
I did.
Okay.
It says the same thing as her. It's not really the right answer.
I think you forgot it. You're missing something, but I don't know what you're.
Okay, we'll have to go and look at it in a minute, if that's okay. Okay, we're on the clock here, so.
I don't know.
Okay, we'll help you out when we're done. I'll sit down with you. Okay, so using this procedure, this idea, we're gonna look at composite figures. Composite figures are when we put two or more figures together, okay? And there's different ways you can do them. I'm gonna start with this one. I probably end with this one, looking at our time here. But if you have something like this, okay? Now, this is an interesting one because this is not composite. Sometimes you have like something like this, you know, and then like this, and you can add these two together, you know. But this one is actually, you took a piece out, right? So I'm going to tell you that this is 4 meters, and this is 4 meters, and this is 6 meters, and these are right angles, okay? So if I had a full rectangle, what would I multiply to? Oh, this is 5 meters. If I had a full rectangle, what would I multiply together?
5 and 6.
5 times 6. So the whole rectangle is the area of the rectangle, right? Is 30 meters squared, right? Right. Well, how could I find then the area of this? We know it's less than 30. Well, what would happen if I finished this, right? And I found the area of this triangle, right?
I don't know why.
You got it?
I think so.
Okay, so if I found the area of the triangle, then I could just subtract it, couldn't I, from the whole rectangle? All right, so take a look at this. If I split this up, this is a right angle. This is, how far is it from here to here? 3. And from here to here?
3.
All right, because the whole thing is 6, right? I know that the area of the triangle is 1/2 base times height, right? All right. I know the base is 6, but I got to find the height, correct? Correct?
Yeah.
So if this is 3 and this is 4, can I use the Pythagorean theorem to find the height?
Mm-hmm.
All right, so the height is little h, this little h right here. The height is, the height squared plus 3 squared equals 4 squared. Is that true? If I use the Pythagorean theorem? Right? So then h squared plus 9 equals 16, correct? So h squared, if I subtract 9 from both sides, is 7?
Yep.
So h is the square root of 7. Not a pretty number, right? So this height is the square root of 7. So what I'm going to do is I'm going to take 30 minus 1/2. Remember the 30 minus, because we're going to take the whole rectangle, minus, and I'm going to use 0.5. I'm going to put this in parentheses. 0.5 times the base, which was what? What's the whole base?
5.
Be careful. What's the whole base of the triangle?
3.
No, that's half the base. 6. Remember, the whole thing was 6, wasn't it? Okay? Times the height, which is the square root of 7, right? So now, if you would take 30 minus that quantity, tell me what you get. 22.1 meters squared, right? And there's an idea of a composite where we actually took a piece out. We can add pieces together too, you know what I'm saying? Okay, all right, let's work a little bit. We're on page 756, if one of you want to write this up there. We're going to do 10 through 14 even. So that's what, 3 problems?
Yep.
And then we're going to do 15 and 16. So we're just getting a little small piece here, what we're doing. But it'll take you a few minutes to do those, so, okay?